Hi, and welcome to the second video for section 2.1 for Math 126. Again, this is the second of two videos. And in this one, I kind of separated these and put this guy in here by himself because what we have here is what's known as the difference quotient. Now, anybody taking Math 181, you're going to use this a lot. And so I'm just going to do one example here, but if you need more examples in class, if there's some homework, it's a little tricky, doesn't quite make sense, make sure you have this idea down. You'll see it on the exam. You could see it on the final exam. Again, its name is difference quotient. We'll see what it looks like. So, what the difference quotient is we have f of a plus h minus f of a all over h. And of course, h cannot be 0, because what would happen? This would be undefined, right? So this, by definition, is the difference quotient. Again, you're going to use this a lot in calculus. But how do I apply this now in 126, and more specifically in this section about functions? So let's say, actually let me write this up over here. Let's look at an example. Let's say I have the function f of x is equal to 2x squared plus 3x minus 1. If I want to know the difference quotient for this function, I have to do what? I have to find f of a plus h. I have to find f of a. I take the difference and then simplify. And the reason we do this is what? Right now we have h in the denominator, and h can't be 0. But in calculus, h is going to go to 0. So we need to figure out a way to rewrite this guy so that we no longer have the h in the denominator. That way 0 doesn't become an issue for us. So the first thing we need to do is let's find our f of a. That was pretty straightforward. If you remember at video 1, what do? We just change out anything that was an x to an a. So f of a would be what? 2a squared plus 3a minus 1. Again, f of a, we're just going to plug in a anywhere that we have an x. F of a plus h gets a little more tricky, a little more difficult for people. But what does this mean? It means we plug in a plus h anywhere that we have an x, and then we'll simplify it. So that becomes what? It becomes 2a plus h squared plus 3 times a plus h minus 1. So I need to simplify this thing because I'm going to have all these terms so that I can subtract the two of them in the numerator. So we get what? We get 2 times, well, this guy, remember back to our binomial expansion, the binomial theorem. It's not what? It's not a squared plus h squared. That doesn't give us our binomial. So we have what? We have to FOIL this. So it's like what? A plus h times a plus h. And if you FOIL that, you get a squared plus 2 times ah plus h squared. Again, I just took this, wrote it side by side so I could FOIL it, and that's what I get when I FOIL it. And then here I have plus, I have to distribute the 3, so I get plus 3a plus 3h and minus 1. So now if I distribute this 2, I get what? 2a squared plus 2 times 2 is 4ah plus 2 times h squared. And then what's left? Plus 3a plus 3h minus 1. So now to do the difference quotient with this function, I have f of a plus h, which is that last line, so 2a squared plus 4ah plus 2h squared, so let's call this step 3, plus 3a plus 3h minus 1. This one is this guy here, f of a plus h. Then we have what? Minus, and you can see I'm using parentheses because I have to be careful with this minus sign that I distributed to every piece. So what is my f of a? It's 2a squared plus 3a minus 1. And this is all over h. And so this piece was my f of a. So if I distribute this negative sign, what do I get? I get minus 2a squared minus 3a. Negative, negative is positive, so plus 1. Now let's combine the numerators. Let's see what happens here. This is what should happen. We have what? 2a squared minus 2a squared. So those two cancel. And then plus 3a minus 3a. So those two cancel. And then minus 1 plus 1. So those two cancel. And again, this guy we wrote up here, so I'm not worrying about the black writing there. So the only thing I have left is what? 4ah plus 2h squared plus 3h all over h. So what do we notice now about this numerator? There's an h term, an h term, an h term. So I can do what? I can factor out that h. And I'm left with, if I factor out the h here, I have 4a. Factor out one of these h's, I'm still left with 1, so I have plus 2h. And if I factor out this h, I'm left with plus 3. And this again is all over my original h from the formula. Why did I do that? Well, hopefully you can see what happens here. This h cancels with that h, no longer in the denominator. So I'm not worried about it becoming undefined. So my difference quotient for this function then just becomes 4a plus 2h plus 3. And that's it. So that's the idea of the difference quotient. Again, you need to know this for your in-class exams. You're going to need to know this for the final exam. How do you do it? You have this formula. Find f of a plus h. Find f of a. Take the difference. You should get a bunch of stuff canceling out. When you do, you're left with a polynomial that has an h in every term. You factor out the h, it cancels, and you're left with just the difference quotient at that point. So again, that was end of video 2 for section 2.1. Come on back and we'll look at section 2.2.